Okay, over here I'm going to break one law that an object can travel faster than light. Okay, these are the light spheres that is sparked off. It is the same as I've shown in the water wave demonstration. You must have seen that video. Okay, so an object travels from A to F at a velocity 1.5 c. Now the light sphere is sparked off at A has reached this big. Okay, this big. Because it expanded at the rate of c and the object moved at the velocity 1.5 c, the object has already crossed this sphere and gone beyond. Okay, similarly is with these spheres of D, E, B and G. One more thing, we are considering over the light is not variable. Okay, only that the object is traveling faster than light. So here you can see it has made a light cone. Okay, this is analogous to a sonic boom and to the demonstration in the water waves. Okay, now let's consider three observers. The one situated at H will be able to encounter Doppler effect and will see the object to be going forward only. Okay, but for an observer situated at I, it will encounter the sphere of F first, so it will see the object to be at F first, then at G, then at B, E, D and A, so that it will see the object to be going back. For I, the object will be running back in time. Okay, which is totally imaginary, for it has never been seen or proved that time can also go back. Okay, so for in this case I will see the object to be going back in time. Okay, an observer situated at J, somewhere between I and H and above this. Okay, see what happens with this. Actually these spheres are at different distances from J, so but they are moving with the same rate towards J, so that those that are farther apart will reach J later than those which are closer. Okay, now here what happens, there is one of the spheres that is situated in between A and F, one of the points situated between A and F, whose light sphere will be closest to J and will reach it first. So J will see the object to be at that point. Let it be E over here. Then there will be spheres on both the sides. There will be points on both the sides of E that will have their light spheres to be at equidistant from J, so that their light spheres reach together at J, and J will be able to see the object to be situated at two places. Then what happens? Similar light spheres come at J, and J encounters multiple imagery. It encounters the object to be at both the places. Like after seeing it at E, it will see that to be at B and D, then G and somewhere between A and D, and then A and F, so that it will see the object to be going forward to and backward to. Okay, in every other case where object traverses the path in less than that of speed of light, there is no multiple imagery. Okay, but for the case of J, body is both going back and forth. I missed out one thing over here that is very important. Okay, I talked about the observer situated at H, at I and at J, but if I were to travel this path A to F at 1.5 c, and when I reached F and turned around, I'll be able to see myself. See? I'll turn around, I'll be able to see myself at G first, then B, then E, then D, and then an F. So I'll be able to see myself going back in time. Let's consider the case when light speed is taken as variable. Okay, over here it's so easy. The object traverses the path from A to F on 1.5 c with these light spheres sparked off at A expanding at the rate of c, but their center moving at the velocity 1.5 c. As they move at 1.5 c and the object reaches F, they too are situated at F with all the light spheres being concentric. These are not the light spheres of this point F, I'm telling you again, but are the light spheres of all these points in between A and F. Okay, but all the light spheres of A and F that are moving with the velocity 1.5 c, and for they are traveling at the same velocity, they remain at rest with respect to each other and are concentric. But what happens when the object stops at F and only these light spheres move forward and keep on expanding? Let's see. Over here I've actually made it, the scale is of 1:3. Okay, considering this sphere, considering the larger sphere over here, in scale 1:3, as time passes this expands and the center moves at a velocity 1.5 c. So it comes over here and then over here. So let's consider an observer over here and then over here. So that let's consider an observer situated at Z. It will encounter the sphere on this side, and after some time it will also, when seeing it to be over here, it will see the object to be situated not at A, but at the center of this sphere which it encounters. Okay, now secondly, it will encounter another sphere inside this larger sphere which has already moved forth, so that it will see the object to be situated not at the center of the larger circle but the center of the smaller circle which has traversed at the velocity 1.5 c, so that it will see the object to be not over here but over here, then over here, then over here, then over here, until this observer Z comes halfway between these two spheres. After that, what will happen is something strange. It will actually encounter the inner side of these spheres, the inner side of these light spheres. Okay, now this is a bit difficult and I had great difficulty in understanding it, but still I inferred something. Maybe my conclusion is wrong, maybe my inference is wrong, but still I'm telling you. These spheres are actually moving in this direction, and the person over here is facing to the left, spheres moving to the right. Light is encountered by the eyes of this observer, and what he sees is the object. But where does he see the object to be situated? He doesn't see the object to be situated at the center of these spheres, because he is not facing towards the center. Actually, he just gets the glimpse of it. For example, of whatever sphere he encounters, he actually sees the object to be situated at an equal distance in front of him. That distance is actually equal to the radius of the sphere. Okay, so think about it. If if this observer comes over here at this point, let me mark it. Okay, if he comes over here, he will encounter the sphere. This sphere is the image of the body, and it will look like the body to be situated over here. But instead, the observer situated over here will see the body not to be situated over here but to be situated over there, and this distance is equal to this distance, this radius of this circle. Okay, it is because the person is facing towards outside. If he turns around, he will not be able to encounter this light sphere. Okay, he will not be able to encounter the light sphere. Only that he faces towards the outside of the sphere will he encounter it, and will see it to be situated outside or somewhere else. Thank you.